Hey boys and girls, brace yourself for I'm about to take you on a mathematical journey back in time to uncover one of the greatest techniques ever created. How to multiply two numbers without using any form of multiplication. And just for kicks, I'm going to add my own mathematical proof to show you how this amazing method works. Alright, so let's get straight into it. All you'll need is the ability to add two numbers. Right, so this entire technique focuses on adding two of the same number together. You'll see when you get there. You maybe want to grab a pen and paper if you want to follow along, but apart from that, you'll just need a bit of other trivialities. Okay, let's jump straight into it. 5 times 7. Yep, we all know that equals 35, yeah? But let's apply this ancient Egyptian method to it. First, roll up a couple of lines like this. Don't need to use an actual ruler, just draw a quick table, yeah? On the top left segment there, put down your first number. Top right, put down your second number. 5 and 7. Alright, so let's focus on the left column for now. What we want here, going down, are the powers of 2, starting from 2 to the power of 0, which equals to 1. Next, we're going to go down 2 to the 1, which is 2, so forth, so forth. If you don't really understand that, try this. Starting from 1, add 1 to itself, you get 2. Then add 2 to itself, you get 4, and so forth, so forth. Next, we're going to, on the right hand column, we're going to start with 7. Right? Just put down your beginning number right next to the 1 there. And we're going to do the same thing, so add 7 to itself, you get 14. Add 14 to itself, you get 28, and etc, etc. Now here's the fun part. From the powers of 2 column, pick as many numbers as you need to make the top number, right? So, there should only be one unique solution to this, which is 1 and 4. Now, the 1 and 4 here, they correlate to 7 and 28 on the other side of the table, so let's select those as well. Here's the fun part. You add the 7 and the 28, and you get 35, which is 7 times 5, amazingly enough. Of course, it works the other way as well. It's put 7 on the left, 5 on the right. We've got our powers of 2 there, and our doubling of 5 on the right hand column. So, the powers of 2 that make 7 are 1, 2, and 4. This correlates to 5, 10, and 20. Add 5, 10, and 20, we get 35. Same deal. Next, let's head on to something a bit hefty. 27 times 634. Now resist all temptation to quickly grab your calculator and punch in those numbers. No. We're going to have a shot and do something we've all learnt at school. Long multiplication. Okay, so 4 times 7 is 28. Keep the 8. Carry the 2, and screw that, because we're going to experiment with this entirely new technique. Or should I say old technique? Okay, let's roll up the table from before. Put our 2 numbers up there. Knowing that order doesn't matter at all. Powers of 2, right? This time I'm going to show you how to actually quickly get your powers of 2 adding up to the number you want. So, I've wrote up the number, I've wrote down the numbers of 2, powers of 2, down to the number larger than 27, right? Which is 32. 32 it being larger than 27. So we instantly ignore the large number and circle the next number up, which is 16. Now, if we add 16 to the next number up, which is 8, we get 24. 24 is still smaller than 27, so we circle 8 as well. Now, 24 plus 4 is 28. That's larger than 27, so we cross that one off. And so forth, and we'll also circle 1 too, because that's the solution. Now this part requires a bit of mathematical knowledge and just a bit of quick thinking with addition and whatnot, but fill out the table on the right hand side. Once you've done that, correlate your numbers, add them up, and we get 17,118. Now if you punch 27 times 634 into the calculator, what do you get? 17,118, of course. Alright, now it's the time we've all been waiting for, how to actually prove this works. Let's go back to our original equation here, 5 times 7. We can rewrite this as 7 times 5, amazingly enough. From our table we found out that 1 and 4 equal 5, so let's substitute 1 plus 4 to 5, which we get 7, and in the side brackets 1 plus 4. If we expand the brackets, we get 7 times 1 plus 7 times 4. Now if we consult the other table, we get that 7 times 1 is 7, and 7 times 4 is 28. Now, add those two numbers, 7 plus 28 is amazingly enough 35, and that's our answer. Now, that's pretty much it, guys. Just read my description, comment appropriately, whip out the Doritos and the cranberry juice, and we're done for this week. Next time, I might have a shot at using division, actually dividing without using division, using the same method. But in the meantime, have a good one, everyone.